Alrighty, so this is my solution for homework number 9. This is the square rooter. So the way this works is I greatly simplified the constraints, and I'll explain why. So this takes any 8-bit integer in and then converts it into a 4-bit root. And it only does between 0 and 9 so that it fits on a single segment on the 7-segment display. And this showcases the approach without overcomplicating it. So the reason I did it this way is because if you want to actually take the square root without brute forcing it with a lookup table, which is essentially what this is, then you have to use bitmath. And the bitmath for this problem is actually kind of complicated, and I ran into several issues. And when you're only dealing with an 8-bit integer, you could easily handle the entire lookup table. And I just decided to do a portion of that, 0 to 9. So all we need is our switches as an input and our anodes, segment display, and LEDs as outputs. We need 2 signals, one to hold the input number and then another to hold the output as a root. And then we just set our anode on, which is number 1. We convert our switches to the unsigned integer. We turn on our LEDs alongside the switches so that it's easier to tell what we've activated. This is just for ease of use. And then we begin our actual lookup process using a switch case statement on the num. We use ranges. Another way you could do this is hard coding every single integer, but I figured ranges works just fine. And we're not rounding, we're basically cutting off, so we're rounding down in all cases. And once we get to 9, we stop basically. So anything higher than 120, which would normally be 10, we just keep it at 9. We could turn the LEDs off completely, but I thought that was even more confusing, so I just decided to keep it this way. And then we do our typical 7-segment display driving on it. So let's take a look at this thing in action. So by default, it's at 0. Once we have a single input, it's at 1. 3 will also be at 1. But once we get to 4, as you can see, 4 gets us the square root of 2. And, this would be 8 plus 1, 9. Here we have 15. And we can kind of just keep going up the list. So this, I believe, is the smallest. Is this 36? Yeah. So there's 36. Or there's 36. So it's very simple. And it's extremely fast because it's just using a case statement. And I think it's a perfect solution for a problem this simple.